Good day, grade 11 learners, and welcome to this video where we will be revising the topic on population ecology, which you will be studying for your paper 2 of your final examination. Please note that this video focuses on questions taken from section B of past paper 2 that I have compiled together. The following are some of the important concepts that you need to remember when studying population ecology. Firstly, factors influencing population size. There were 4 factors that we discussed when we spoke about factors influencing population size, namely natality, mortality, immigration, and immigration. Natality referred to the birth rates in a population. Mortality was the death rates. Immigration is the one-way movement of individuals into an area, while immigration was the one-way movement of individuals out of an area. We then looked at 2 methods that can be used to determine the population size: mark recapture technique and quadrant sampling technique. Each of these methods had their own formulas that can be used to determine the population size, either using the mark recapture technique or using the quadrant sampling technique. You need to be able to know how to perform a calculation using both the mark recapture as well as the quadrant sampling technique. You may be expected to perform a calculation using the mark recapture or the quadrant sampling technique. Please make sure you know exactly what formulas you are going to use when calculating each technique, as either one of it could be asked of you. Then interactions in the environment. There were different types of interactions in the environment that you would have studied in this topic. Firstly, competition. There were 2 types of competition, namely inter and intra-specific competition. Predation, resource partitioning, symbiosis, where we would have looked at mutualism, commensalism, parasitism, and then also competitive exclusion. There were different types of population growth forms that you would have studied in this topic, namely geometric growth as well as logistic growth, where geometric growth was the J-shaped curve, while the logistic growth form was the S-shaped curve. Then the differences between density dependent and density independent factors. You need to know what the differences are between the two, as well as describing some density dependent factors and listing a few density independent factors. Remember that density dependent factors are different from density independent, because density dependent factors are going to be occurring depending on population size, while density dependent factors are going to occur regardless of the size of the population, as density dependent factors are going to be things like extreme climatic conditions. So floods, droughts, earthquakes, tsunamis, etc. Then human population. When we discussed human population, the main focus was on the interpretation of population pyramids and trying to come up with some reasons as to why some countries can be regarded as developed countries, while other countries are going to be regarded as developing countries. So the differences between developed and developing countries when studying population pyramids, that was mostly what you looked at when we touched on human population. If we look at our first question, it's a question from a 3.2 that says rabbits were introduced to an Eastern Cape farm in 2006. Since then, the rabbit population has increased rapidly. The graph below shows how they increased. So if we have a look at this graph here, if you look at the shape of the graph, then it goes without any doubt that the type of growth form that we have here would be logistic growth. We have the year on the x-axis and the population size on the y-axis. And each phase has been named with a certain letter. So A, B, C, D, and E is pointing to this dotted line. 3.2.1 asks us to provide labels for phases B. So if we go to B, this phase where the population size is increasing drastically is going to be referred to as the accelerating or exponential phase. Remember, the first phase of the logistic growth form is going to be the lag phase. You then have the exponential or the accelerating growth phase, the decelerating phase, and then lastly you have the equilibrium phase. The next phase, C is going to be that phase there referring to the decelerating growth phase. 3.2.2 asks you to name the type of growth form shown in the above graph for 1 mark. The type of growth form here, since it's showing a S-shaped graph, therefore it's going to be the logistic growth form. 3.2.3 says give the letter of the phase where the birth rate equals the death rate. So the phase where the birth rate and death rate are going to be equal to each other is normally going to be in the equilibrium phase. Therefore, the letter of that phase is going to be letter D. When natality exceeds mortality by far, your natality, your birth rates are generally going to be much higher than your death rates in your accelerating growth phase. Therefore, the correct letter is going to be letter B. Explain why the rabbit population size did not increase permanently after point E. So after point E is referring to something. This line that is pointing to this dotted line, it's showing you something. What is it actually speaking about? This dotted line that you have here is going to be referring to your carrying capacity. Carrying capacity refers to the maximum number of individuals that an environment can comfortably support. So the question says, explain why the rabbit population size did not increase permanently after point E. So point E is the maximum carrying capacity. So the rabbit population had reached carrying capacity. You can see the line stopped there. And because it reached carrying capacity, something is going to come into play, referred to as environmental resistance. Environmental resistance occurs, density-dependent factors prevent population from increasing. Things like food, space and water, it becomes limited. Environmental resistance is going to come into play. Density-dependent factors will come into play. The rabbit population will experience a shortage of food, space, shelter, water, etc. This prevents the population from increasing further. So let's re-explain 3.2.4. We see the rabbit population reached carrying capacity, the dotted line. Environmental resistance came into play. This is going to cause density-dependent factors to start occurring, where the rabbit population experiences a shortage of food, space, water, shelter, etc. And this then prevents the population from increasing further. 3 marks for 3.2.4. Here are 3 points that you would have given for 3.2.4. The next question, 3.2, says dandelions are weeds that often grow on school sports fields. The groundsman at a school is responsible for making sure that the soccer field is well maintained and has no weeds. So you don't want weeds on your soccer fields. He wanted to calculate the number of dandelion weeds on the soccer field. The size of the soccer field is 2,500 meters squared. He used 1 meter by 1 meter, which comes to 1 meter squared quadrants, and took 15 samples across the field. The number of dandelions in each sample were recorded in the table below. So you have the sample numbers 1 to 15 and the number of dandelion plants recorded in the table. This is what the dandelion plant looked like. The first question, 3.2.1, asks us what is this method of estimating population size, all for 1 mark. So since we have the size of the soccer field in meters squared, we have the size of the quadrants. This is indicating to us that the type of technique that we have, so it's either going to be between the mark recapture and the quadrant sampling technique. Since we have area here, that is a great indication that the type of technique that we are looking at is going to be our quadrant sampling technique, since we have areas given. And in a quadrant sampling technique, the formula provided to you normally has area of the quadrant as well as area of the entire habitat that you are studying. 3.2.2 says the groundsman did not know where to place the quadrants on the field. So he did not know where to place the quadrants on the field. Explain how he should go about determining where to place them. So explain how he should go about determining where to place them for 2 marks. So generally, if you are going to be placing quadrants in order to determine your quadrant sampling technique, then you need to ensure firstly that the samples are going to be random, and the samples should also represent the whole area that you are looking for. So firstly, the samples should be random and the samples should represent the whole area. That is what the groundsman needs to do. Secondly, 3.2.3, calculate the total number of dandelions on the field for 5 marks. You are therefore going to show your calculations and you need to know exactly what formula you are going to be using here. To perform a calculation using the quadrant sampling technique, you are going to use the formula where you first need to calculate the average number of dandelions that are given. So the first step, you're going to calculate the average number of dandelions. Here is your number of dandelions. To calculate the average, you're going to add them all together. And since there are 15, you are going to be dividing by 15 because when you calculate the average, you add all numbers divided by the total numbers that you have. So you say 22 plus 3 plus 7 plus 4 plus 15 plus 0 plus 12 plus 3 plus 0 plus 14 plus 4 plus 7 plus 2. You're adding all these numbers together. You're dividing by 15. Why? Because there are 15 samples. You type this into the calculator and you should get 6,4. So 6,4 is the average. The next step, to get the total number of dandelions, you are going to use the formula where you are going to take your average multiplied by the habitat size divided by your quadrant size. So your average multiplied by your habitat size divided by your quadrant size. You calculated the average in your first step, 6.4. The quadrant size here, it was given to you. The size of the soccer field is 2,500 meters squared. Divided by the quadrant size. They gave you the quadrant size in the question and the area was 1 meter squared. If the areas were not given to you and units of measurement dimensions were given, you first needed to calculate the areas and then insert the areas into the formula. If you type this answer into the calculator, it should give you 16,000. And what are you referring to here? What is the unit of measurement? It's dandelion weeds because that is what we are calculating. So you will be awarded 5 marks for performing this calculation. The first step, you calculated the average using the values in the table. Next step, you calculate the total number of dandelions using the formula. Notice that the formula was not given to you here in the question. You need to have memorized the formula for determining your quadrant sampling technique, where you are going to take your average multiplied by your habitat size, that's going to be in units squared, divided by your quadrant size, that's also going to be in units squared. In this case, it was in meters squared. 3.2.4 says, why were 15 samples taken instead of 5? So 15 is more than 5. What did you do when you chose 15 samples instead of 5? You increased your sample size. And increasing your sample size is one of the things that we are doing when we want to increase or improve our reliability of an investigation. That is some of the things that you would have learned when you spoke about scientific method. Some of the things you can do to increase your reliability or to ensure your validity. Those were things that you would have studied in scientific investigations. So when you increase your sample size from 5 to 15, you are increasing your reliability of the investigation. 1 mark for that question. 3.2.5 says, give one reason why the groundsman would want to know the total number of weeds on the field. For what reason would the groundsman want to know how many weeds there are in the field? So first, to know how long it will take to pull out all the weeds. To know how much weed killer or herbicide he needs to use. Because what is his purpose? He needs to ensure that there's no weeds on the field. So if he knows the total number of weeds that there are, he can know how long it would possibly take him to remove the weeds or how much weed killer or herbicide he needs to purchase so that he can use this weed killer to actually kill the weeds on the field. The next question, 3.3, says tabulate two differences between a developed country and a developing country that affects their population growth curve. So 5 marks. This is a question that can be expected, that you can expect to receive in the exam, where you are going to tabulate the differences between a developed and a developing country. First and most importantly, please ensure that you draw a table. If asked to tabulate differences, you need to draw the table because you are awarded 1 mark for drawing the table. 1 out of 5 goes to drawing the table. Then, on the left-hand side, you're going to have your developed country. On the right-hand side, a developing country, and you state the differences. I'm going to go through a few differences that you could have stated. Any 2 of these differences would have been acceptable. In a developed country, they have good medical care. In a developing country, poor medical care. In a developed country, low birth rates. In a developing country, high birth rates. In a developed country, low death rates, but in a developing country, high death rates. In a developed country, high economic standards, high standards of living, but in a developing country, low economic standards, low standard of living. Because there are lower levels of education, but in a developed country, there are higher levels of education. Therefore, there are higher economic standards and higher standards of living. Any 2 differences along with the drawing of the table would have given you 5 marks for this question. Please make sure you are able to tabulate the differences between a developed and a developing country. The next question is 3.3 that reads the population pyramids below shows the population percentages of South Africa and Nigeria. The first one that you have here, you can see percentage of males, percentage of females, the first population pyramid. It says South Africa in 2020 with the population size. The next one, you see it's a population pyramid of Nigeria in 2020 with a certain population size, also broken up into percentage of males as well as the percentage of females. And as you can see, the ages are here on the left-hand side on the y-axis. The first question, 3.3.1, says define the term population. Remember, you need to be able to differentiate between the term population and a species. If they're only asking you to define a population, you can simply say it's a group of organisms of the same species occupying the same habitat at the same time. That phrase is very important, occupying the same habitat at the same time. 3.3.2 says what percentage of the male population in South Africa is between 15 and 19 years old? Male population in South Africa. This is the population pyramid for South Africa. We are looking at this population pyramid. We are looking at our males. The males are going to be on the left-hand side, 15 and 19 years. We're going to look at our ages here, 15 and 19 years. That is what we are looking at. So this is the bar that we are reading, and therefore we are going to get the percentage here, which corresponds to 4%. We read the percentage from the x-axis. 3.3.3, which age group makes up the greatest percentage of the population in South Africa? Here are the age groups. Which one makes up the greatest percentage of population in South Africa? It says 5 to 9 years old. Where did we actually get that from? We look at the bars here that are going to be the longest, the greatest percentages, and therefore we see that the longest bars out of all the bars here was 5 to 9, therefore 5 to 9 was the answer. 3.3.4, which group, males or females, has a higher life expectancy in both countries? Males or females? Which one has the higher life expectancy? If we look at the percentage of males, higher life expectancy, we go to the top. There is no bars here. But for the females, there are bars here for 9 to 94 years old, pink bars. If we go over to Nigeria, there isn't really a lot of bars here for the males as well as you go higher up. But for the females, there are. Therefore, the answer is going to be females. High life expectancy means that you are going to live to an older age, and therefore we selected the females because the bars increased still until the top, where for males it started dying out. The next question, 3.3.5, says which pyramid represents that of a developing country? Remember that a developing country is going to have a population pyramid that is normally going to be in the form of a triangular shape. And between the two population pyramids, the one that has a more triangular shape is going to be that of Nigeria. Therefore, the answer is going to be Nigeria. Give two reasons for your answer. So why are you saying Nigeria is going to be a developing country? A population pyramid that has a triangular shape is generally going to have high birth rates. It has high birth rates. It has high death rates since the life expectancy is low, and therefore it's going to have a short life expectancy. Any two of these reasons would have been correct. High birth rates, high death rates, lower or shorter life expectancy. 3.3.7, name one density-dependent factor that normally stops populations from growing in animals. Any density-dependent factor, you could say the outbreak of a disease, the lack of food, the lack of shelter, the lack of water, etc. Any of those you could have listed as one density-dependent factor. 3.3.8, explain why the factor mentioned in question 3.3.7 has failed to control human populations. So why does this factor, the density-dependent factor, why did it fail to control human populations? So you could have chosen any one of the factors that you mentioned. If you had disease as your answer, you would have then explained why does disease fail to control human populations. So I just selected disease as the one that I inserted here. So humans have developed medical technology, so there are fewer deaths. So over the years, humans have developed medical technology, so there would be fewer deaths and fewer outbreak of certain diseases. The next question, 3.6, says study the diagrams below showing the population pyramids of Malawi and Japan. So on the left-hand side, we have Japan, and on the right-hand side, we have Malawi. Again, it's broken up into male and female on either sides. The first question, 3.6.1, says which of the countries represented in the population pyramids above is a developed country? Remember, a developed country will not have a triangular shaped pyramid. It's going to be similar to the one on the left. Therefore, we are going to say 3.6.1, Japan would be the answer. 3.6.2, which give one visible reason for your answer in 3.6.1. Why are you saying Japan is a developed country? The population pyramid shows a population with declining numbers. So population with declining numbers. That's one correct answer we could have had for 3.6.2. 3.6.3, from the graph, what can you conclude about the age group 0 to 19 years in Malawi? 0 to 19 years in Malawi. What can we conclude here? We see the bars are still very long. So most of the population is between the ages of 0 to 19 because the bars are very long, so population numbers are very high there. And this is going to be an indication of an increase in population. What do we mean by that? The population is continuing to grow in numbers. 3.6.4, name 4 factors which can cause the composition of the size of the population to change. Those are the 4 factors that we stated at the start of the video. So things like natality, mortality, immigration, or you could also state any density-dependent factor. So things like diseases like HIV, immigration, a lowered birth rate because of a crisis such as an economic crisis. 3.6.5, explain why it's important for the government of a country to have access to population pyramids. For 3 marks, why does the government need to have access? The government needs to know how many children there are in the country, to know how many schools to build. They need to also know what the housing needs are. They need to know how much education How much of education facilities do they need? What type of infrastructure do they need to build? How many hospitals do they need to have in the country, etc. That brings us to the end of this video. Just to ensure, these are the topics that you need to study for paper 2, biodiversity classification of microorganisms, biodiversity in plants and reproduction, biodiversity in animals. In this video, we also revise population ecology. In the next video, we will look at human impact on the environment. Thank you very much for taking the time to watch this video. I hope to have you all join me in the next video, which will be on human impact on the environment. We will look at section B questions of your paper 2 in your final exam.